Right, so today we resume our lecture. This is the last week before the semester break. Okay, next week you're gonna have 1 week break, and we're gonna finish LU2 today, inshallah. So there are 2 lectures. Well, actually, it's not that really different things, but we just divide the lectures into lecture 6 and lecture 7. So if you see later the PowerPoint files on eLearn, lecture 6 and lecture 7, but those 2 topics are actually related. Okay. So before I go into lecture 6 and lecture 7, let me show the eLearn page. For those who just joined, you can scan the attendance later at the end of the class. If you can't hear me, just shout. Just stop me anywhere, because I'm not sure whether or not during the class later my voice is clear or you cannot see the screen. You just stop me. Yeah. Let me share the elite. Okay, can you see the elite page, which is this one? Can you see the elite on your screen? Yes. Okay, thanks. Okay, so let's just recap what we have learned previously, especially on LU2. So we started LU2 with discrete distribution and then continuous distribution. Under continuous distribution, we learned about normal, sampling distribution, central limit theorem. And then we continue with confidence interval T distribution. And after that, last week we focused on hypothesis testing, right? And we have 2 situations, and this one, actually last week, we just concerned with 1 sample in a population, hypothesis testing for 1 sample in a population. And there are 2 situations given. The first one is when the standard deviation is known, where we use Z distribution. This is the summary of the steps that we need to do in order to perform the hypothesis testing for the situation. Okay, and the second situation is when the standard deviation is unknown, right? And we use T distribution, and this is the steps. So there are similarities where you have to set the hypothesis, and at the end you have to make a conclusion and also decision. The difference lie in the middle steps, where for this case, for when the standard deviation is unknown, you use T distribution. Okay, so both of these refers to 1 sample in a population. So what we are going to cover today, we are still on hypothesis testing. It means that we want to test our hypothesis and we want to decide which hypothesis that we want to conclude. Okay, but in order to conclude that, we have to perform certain steps. Okay, so that is what hypothesis testing is all about. But in this lecture, today's lecture, we are going to see 2 sample population. Last week we see only 1 sample population, meaning to say that we make a conclusion based on 1 sample. We just analyze 1 sample and the population. But in this topic, 2 sample population. Okay, this is actually from last semester's class, when we have the physical class where I sketch the things on the whiteboard. Okay, can you guys see this picture very clearly?
Yes.
Yes. Okay, so for today's class, lecture 6 and lecture 7 is summarized into this overview. Okay, so 1 sample here we covered last week. So let's focus on 2 samples, the one on the left and on the right at the bottom here. Okay, So if you see one sample, there are two situations, right? Last week we studied about when known standard deviation, the standard deviation is known, and when the standard deviation is unknown. So for known, we use Z in order, we calculate the Z and we compare with the Z table and make decision based on the comparison. And for the unknown standard deviation, we find what is T based on this formula, and we compare the T table and T calculated and make decision based on that, right? For today's topic, we focus on two samples, but what you can see is like the Z formula is extended, yeah, considering 2x, because we are talking about two samples. So this is the formula. So let's go through the formula and things here first, before we go into detail later. This is when the standard deviation for sample 1 and sample 2 are known. So this is the formula. So the idea is the same. We calculate the Z, right, but using this new formula, and then we compare the Z, the calculated Z with the Z from the table and make decision based on that. So actually there are similarities with the previous topic, yeah, but it's just that it's a little bit extended in terms of the formula, but everything is the same after that and before, where you have to make the hypothesis, and then this is what you have to calculate, and then at the end, make decision and conclude. Okay, that's the similarities. For the unknown standard deviation, yeah, two samples. This one is a bit lengthy compared to when the standard deviation is known. Okay, for this one, it's divided into two cases, yeah, sub cases. The first one is independent samples, and the second one is dependent samples, dependent or paired samples or matched samples. Either one is okay. Yeah, is considered. Yeah. Okay. So for independent samples, there are two more situations where the variance is equal between the two samples, and the second one is when the variance is different. But you don't have to worry about different variance because we are not going to focus on that in this topic. Yeah. So for equal variance or pool variance, pool means pool accumulated variance. So that will be the focus in this part. Okay. So this is the formula for SP. S is the variance, S square is the variance, P is pool. Yeah. And this is the formula. And later I will show it clearly on the screen on the PowerPoint slide. This is just to give to you the basic idea. So you use this SP formula in order to calculate pool variance, and you use that SP squared term in order to calculate T later. So this is extension formula of T. Okay, I'll show it later. That is for independent samples. So what is meant by independent samples? The two samples are independent. They can stand by their own. They are not associated. Okay, independent. Whereas dependent samples or match or paired samples, they are associated. Okay, we'll have a look at how the samples look like for both of these. This one, the formula is quite simple, much simpler, where you calculate the T based on this formula. I'll explain what each of these terms is. And here you have to calculate S first. So how to calculate S? S is standard deviation. S squared is variance. So you get S from this formula. I think you have applied this in the previous topic. Yeah. S squared is variance. This is the formula of it. And S is obtained from the square root of S squared. Okay. So that's how you got the S. And you substitute into this T formula. And you calculate the T, and you compare this calculated T with the tabulated T. Actually, yeah, you have the idea already from the previous topic, where you calculate the T, you compare the T with the table, with the values in the table, make decision based on that, and make a conclusion. Okay, so basically, today's lecture 6 and 7, we are going to look at two samples, the one at the bottom here. Okay, but just to show you here that they are actually associated. There are similarities, with the topic of one sample. Okay, and I hope that when you see the overview here, you can perhaps have a better picture about our lectures, because if you go to the lecture slide by slide later, there is no, yeah, I mean, you have to go back to this sort of overview in order to see the whole picture again. Okay. Any questions so far, guys? Is it okay?
Yes, that's
Okay. Okay, so we go to the lecture slide. Okay, so that is the summary of today's lecture. So now I go into detail each of that. Okay. Wait, I need to share the screen. Okay, so we go first to lecture 6. In this topic, it's we cover first 2 sample in general. Okay. Wait. Right, so in this topic, we're going to cover, as I said just now, 2 samples, right? So 2 samples means 2 samples. 2 samples. You have 2 samples, right? In a population, right? Let's say this is sample 1, and this is sample 2. So what you're going to compare or to analyze between these 2 samples is whether there is a difference or not. Okay. So let's say we have these 2 distribution. So each of the sample has its own distribution. So let's say the green one here is S1. Okay, I'll try to, I will not go from word by word, but I just try to explain the main point of the slide. I hope that's okay. Yeah? Okay, so let's say 2 samples, right? And each of that has its own distribution. So what is meant by distribution is the coverage of the whole data. Okay, so if let's say sample 1, you are talking about the weight of students, a sample of students from FSTS faculty, our faculty. Yeah? So that is like 1 sample. Yeah, and you want to compare the data, the weight of students in FSTS with the weight of students in FK. So FK is another sample. So that is S2 in this case, sample 2. So if let's say you're a sample, each of the sample has a sample size of 50 students, okay? And the whole data of the 50 students is covered by this distribution. So that is what distribution is. Yeah? I hope you understand now what is distribution. And let's say we want to compare the 2 distributions, the 2 data set, yeah? And if we sketch it, so this is actually perhaps how it looks like, the comparison of the 2 samples. So what we need to compare, so of course, in each of the sample, it has its own mean, average, right? So what is the average of weight of students in FK? What is the average of weight of students in FSTS? So that is the peak. The peak here is the mean. Each of these peak is the mean or average of the data. So in statistics, we always concerned with the mean, right? With the average of the average values. Okay, so if let's say we want to compare these 2 samples and we have sketched the distribution. So this is the mean of S1 and this is the mean of S2. So this is how it looks like. The difference is counted from the mean of the difference of the distance or the difference between the mean of S1 and S2. Okay, so if you see the dotted line over here, that is the difference between the 2 means. Yeah? Okay, so what does it mean? What does it mean to say that the average of for 2 groups are statistically different? So in in statistics, the term, when you say that it is significantly different, okay, what does it mean when it says it is not significantly different? Okay, it has its own meaning. It's not to say that it's not the same as we speak generally when we say that it's different, it's not different. But in statistics, what is meant by statistically different, it is actually evaluated based on statistical analysis. Okay, so let's say, can you see the scribbles that I do here, guys?
Yes, doctor.
Yes, huh? Okay. Right. Let's say just now we're talking about S1 and S2. Contoh apa ya? Nak bagi. Okay, the mean, right? The mean of the height, mean of S1. Let's say the mean, the average height of the students in S1 is 160 cm, okay? And S2, the mean is 160, okay, let's say 160.5. I give two conditions, okay? So this is first condition, okay? Condition 1, okay? And condition 2 is when the first one is 160, okay? And the mean of S2, let's say 170, okay? So of course, you can see if, let's say, you can, if you don't analyze using statistics, you can see that the first situation here, where the difference between S1 and S2 is only 0.5, the difference is little, right? And in the second case, where the difference is 10 cm, that's quite significant, or quite obvious, the difference, because it's 10 cm. And you can see that 160, if you want to, this is height, okay, 160 cm, you can see the difference from a person who has 160 cm with a person who has a height of 170. So it's obviously different, right? I mean, you can see the difference. But if, let's say, you see a person with 160 cm with with another person who has a height of 160.5, only 0.5 cm, and this is height. Of course, actually, with your eyes, if you see the two persons, they are about the same, right? You can't see that really much different. Actually, 0.5 cm for a height, you can't really see. I don't know, but I don't know about others, but to me, I can't see, right? Okay, so this is, I'm just talking about generally speaking. So you can say that in the first situation, the difference is not that obvious. It's very little, right? And in the second case, it's very obvious. It's at 10 cm. Okay, but in statistics, we have to test the difference. We have to do like statistical analysis in order to, although that we know that the difference is not much, but in statistics, when we come up with the term statistically different, statistically not different, we have to use certain statistical tests. Okay, so those are the things that we want to actually check in statistics, whether or not the difference of whatsoever. Let's say we have another situation of 160 and 100, a little bit higher than 160.5. Let's say 164. Okay. Okay. So now let's say the 10 cm difference just now, we know that is quite obvious. But how about 160 and 164? Can we say it's statistically different, or can we say that there is no difference? Again, I mean, there's no statistical difference. So that kind of things that require us to do the statistical analysis between the two samples. Okay, so that explains why we have to analyze, why there is a need to analyze two samples, two samples. So in order for us to come out with a conclusion at the end that the two samples, the two mean of the two samples are statistically different, or there is no significant there is no statistical there is no significant difference between the two samples, or yeah, it's either two. It's either there is a significant difference or there is no significant difference. Okay. Right. So you guys understand now? Can you follow me so far? Yes, sir?
Yes, doctor.
Okay, so that explains why we have to analyze two samples, right? And you actually apply it in research. Huh? For example, you want to analyze, you are a zoologist, you want to analyze the samples that you get from one area to another area. Huh? Let's say you are analyzing two areas in Sarawak, maybe Cebu and Miri, in terms of the distribution of bats, for example. So you have to apply the statistical analysis. So that's why we teach you in the first year, so that you have an idea what to do in terms of the statistics on your data. Okay. Right. Isn't it? Okay, so when we talk about two distributions or two samples, so these are different situations that can arise. Okay, so just now I said that if you want to compare the mean, the average of the two samples, you just consider the peak of the distribution. Yeah? This is the peak, what we call it, the peak, the maximum, yeah, or in the mean value, the middle value. Yeah. Right? So, okay, so given three situations here, but you can see that the distance between mean of the first sample and the second mean is the same, is given by the dotted lines. But what differ is in terms of the spread of the distribution. Okay, when we say how big the distribution is, we call it like, I mean, we also refer to the spreadness of the distribution. So what does it mean with the spread is the range. Okay, for example, if let's say the data, okay, the data, let's say I give three situations. So let's say the range from the height just now, we're talking about height, huh? The height. Okay. Case one. Let's say case one. The range of the height of the samples is 150 to 170 cm. This is in terms of the range. Yeah? Okay. Case two. Let's say 100 or okay. 100 is 360 to 100. Okay. So you can see that here there is a difference between the range of the distribution, okay, this is a sample, right? 150 to 170 cm. If let's say I want to sketch it, okay, Oh, sorry. Sorry. Okay, let's say this one is the scale. This one is the scale. Okay. Start from 140. Okay. 140 is here. 150. 160. 170. 180. What's it mean? I'm sorry, guys. Let's see. Much quicker. Hmm. 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 Okay, contoh lah. Okay, this is 140 tadi. Alamak. Ini 140, okay. Sini 180, okay. Ini scale, okay. Let's say I want to draw the distribution. 140 to 180. So the distribution will be like this. Something like this, okay. So let's choose another color. That is 140 to 180, okay. That is the second case. So the first case, 150 to 170. It's only here. I hope you can see well the sketch, even though it's not that really nice. 160 to 170. Okay, 150, 60, 70. Okay, this is 160. I don't label it, but you can see by yourself. Let's say this one is green. Okay, this one is very short. Okay. So all of them have the bell shape, right? But what differs is in terms of the spread. Okay, so if you see, like, for example, in the sample, the data that you have for the height, in this case, this is not just for this one, this is just an example. It can be in many cases. So let's say here, it means that the data that you collect from the sample, let's say the sample has 50 students, the students, for example, in case one, the data range from 150 to 170 cm. So that's what it means. So when you sketch the data, that's how it looks like, from 150 to 170. That is the spread or the distribution. For case two is 140 to 180. And case three is 160 to 170. Okay, so you can see that actually the difference in terms of the spreadness. So that is actually explain the point over here, right? If let's say you have the two samples and you sketch it, although they have similar difference of the mean, which is noted by this, denoted by this dotted line, but the spread can be different. Okay, and the spread is is presented here. Okay, so for example here, the variability between the two samples is medium. Okay, we have a look at first the low variability. The low variability means that the two samples does not overlap that much because of the small range for each of the sample. Okay, you can see that the overlap area is very little. Yeah, compared to if you see the high variability, although they have similar difference of the means, yeah, but this one has a wider spread, both of it, and both of the samples overlap, right? And that's why they have this big area of overlaps. So we can say that the variability is high, yeah, because it's variable. It's like from, let's say, a big range, yeah. And medium is something in between low and high. You can see it's not that really wide, but it's not that really small, the range. So that is medium. Okay, so that is how what happened, what the two samples, the distribution of the two samples can be like. Okay, so this is the possible cases. Okay, so the rest you generate by yourself is actually the same as what I explained. Okay, okay, first, so when we talk about two samples, we go to the first case. That is when the standard deviation, this is referring to the standard deviation, the sigma, this symbol, sigma 1 and sigma 2. We have a look at when both are known, okay? So what we have to do is, these are all the steps. So basically, when the standard deviation is known, the same thing when we go for one sample in a population, remember last week, we use Z distribution, okay? But in this case, because there are two samples, we have to consider this extended version of Z formula, okay? It will be given to you, don't worry, but you have to know what does it mean, yeah? Okay, first let's have a look at the steps. The first and the second step is the same. We have to state the null and alternative hypothesis. But for the hypothesis, we have also to consider the sample 2, the second sample. So because we are analyzing the two samples, so we have to say that the the null hypothesis, there is no difference between the mean of sample 1 and the mean of sample 2. You can say that mu1 is equal to mu2, or you can also say that there is a mu1 minus mu2 equal to 0. So you just actually transfer this one to the right side is equal to mu2. Yeah? For the alternative hypothesis, is opposite to the null. There is a difference between mu1 or mu2, or you can say that this expression, or you can say that it's not similar. Anything that falls into that meaning. Okay. So that is the difference between the two samples and one sample that we discussed last week. We have to consider also the mu2. Yeah? Right. The second step is to set the level of significance, which is alpha. So the same thing, if it is not given, you have to define by yourself, and you have to know that the normal value used is 0.05 or 0.01. Yeah. Okay, so the third step is to compute the sample test statistics. So here we have to use this formula, right? So this expression, the first expression here, you ignore it because this is the final order simplified version. Yeah? Z is equal to x1 bar minus x2 bar. This one refers to the average of the sample 1, average of the sample 2, standard deviation of sample 1, standard deviation of sample 2, and 1 is the sample size of sample 1, and N2 is the size of the sample 2. So sometimes the sample size might not be equal. For example, if let's say just now I give an example of measuring the height of students in FSTS and students in FK as a sample 2, right? So it could be sometimes like the size of sample 1 is 50. Okay, the size of the students at FK, which is sample 2, can be like 49, something very close but not equal. So that's why you have to use the right sample size for each of the sample. So the idea here, we calculate the Z, so we denote it as Z computed, or Z calculated, right? And the next step is to determine the tabulated set, which is the Z from the table. Okay, remember tabulated set is the Z from the table. So how you decide, or how you determine the Z from the table is the same thing. Yeah, just repeat what I explained last week. So the significance value, the significance value, which is alpha, the second step tadi. So if let's say it is alpha is equal to 0.05, okay, so it means that the distribution it actually denotes it actually denotes the tile area, isn't it? But you have to consider both area. I just want to show the tile area and covered by the 0.05. So here is 0.025, yeah? 25. Don't forget to divide it into 2. So that's how you find from the table, the Z table, because we know that the tile area here is 0.025. So if you find the Z value from the table, so you have to know what's the area here. So we know that half of the graph is 0.5. So 0.5 minus 0.025, that will give the value of 0.475, right? 475. Okay. Let me stop sharing this slide in order to show you the Z table. Okay, remember 0.475. I hope you remember that. Huh? I need to show the Z table. Hold on. Okay. Okay, so this is the Z table. We know that the area that enclosed is now is 0.475. So this is Z. The area is inside, so we have to go from inside to outside. Yeah? So we have to refer 0.475 here, right? 0.475. So we need the Z value, which is 1.9, 1.96. Okay, you get it? I hope that you are well versed already with the Z table. Okay. So go back to our slide just now. Okay. So that's how you got the Z tabulated, right? In this case, let's say 0.05, that is 1.96. And you have to compare with the Z that you calculated in the previous step, yeah, with the extended formula of Z just now. So the rule is the same with the one sample, whereby this is the rule of thumb. So you compare both values and you have to make a decision to conclude H0 or H1. H0 is the null hypothesis, H1 is the alternative hypothesis. So this is option 1. Alternatively, you can also compare the p-value. So this is option 2. You don't have to perform both. You just have to choose option 1 or option 2. It's the same because that will guide you with the decision. Okay, for the second option here, you have to compare the p-value and the alpha. So what does it mean with the p-value here? So let's say you have computed the Z in the previous step, in the third step. So let's say the value of Z is up here, 2.23. Okay, how to get the P, I just explained to you, but you can decide later whether you want to choose option 1 or option 2. Okay, I just explained to you what is this P value is. So let's say the Z value that you calculated in the third step, not the table Z value. This is like from the third step. I give, let's say Z is 2.3, for example, 2.3. This is Z calculated. So how to get the P value? So you have to sketch your distribution. Okay, so that, let's say Z equal to 2.3. You have to find what is the tile area here. Okay. Let's say that tile area is the p-value. That tile area is the p-value. Okay. I think you can refer by yourself. If let's say you want to find the tile area, you have to play by the tricks with the set table. But just to show you here, that is how you get the p-value. So that p-value, the tile area, you have to compare with alpha. Alpha is the one that you set in the second step, 0.05 normally, or 0.01. You compare those two values and you make decision whether you conclude H0 or H1. Okay, so that's why I said it will direct you to the same point, whether you conclude H0 or H1. Okay, so you can choose either option 1 or option 2. Which one is you feel that is easier? Okay, after you make the decision, this is decision making, and you have to make a conclusion. So make conclusion means that, so if let's say you accept H1 or the alternative hypothesis, you have to go back to your alternative hypothesis, which you have defined in the first step. And when you define the hypothesis, it must be specific to the case that you are analyzing. Okay, so if let's say you are analyzing the height of the two samples, so you have to make it clear. The mean of sample 1, if let's say you accept alternative hypothesis, the mean of sample 1, the mean of height of sample 1 is not equal to the mean of height of sample 2, or whatsoever mentioned in the question. Yeah, it must be specific. Okay, so those are all the steps for analyzing two samples with known standard deviation. Okay, you use Z distribution, and there are similarities with the previous one that we have discussed. Yeah? Okay, just to make it clear again, two samples, both the standard deviation are known, are given. The steps state the hypothesis, right? You have to state both mu1, mu2 in the hypothesis, set the level of significance alpha, compute the Z, using this formula, and then decide whether you choose option 1 or option 2, right? In option 1, you find the Z table value and you compare with the Z computed from the previous step. Okay, in this option 2, you find the p-value of the Z calculated. Okay, but both of them will direct you to the decision making, where you have to conclude either H0 or H1. And the final step is to make a conclusion based on which hypothesis that you accept in the fourth step. Okay? Any question so far? Any question, guys? Is it clear?
Clear, Doctor.
Yeah, okay, thank you. If you have any question, you can just stop me at any time, okay? Because I don't know whether or not you can understand what I said. I assume that what I said is clear. Okay, so let's have a look at one example before we go into the next topic. A teacher wishes to compare the effectiveness of two teaching methods. The students are divided into two groups, and each group is taught using different methods. At the end of the course, an exam is given to all students. So these are the information. Group 1, which is sample 1, the size is 49 students. The mean score is 74.8. Okay, that is sample 1. Sample 2, N is 50. Mean score is 81.3. Okay, so the question is, the teacher claims that the second method used on group 2 will increase the score. Is this claim justified at the 5% level of significance? Earlier research for the two methods indicates that standard deviation, this symbol is called sigma in mathematics. Sigma 1 is equal to 14 points and sigma 2 is 15 points. Sigma is standard deviation. So apparently it's mentioned in the equation that the standard deviations are given. So you know that this falls into the category when the standard deviations are known. So you have to know that you have to use the Z distribution. You have to calculate the Z. Okay. So what else you can analyze from the question. So it's given clearly the mean, the n size. I just want to highlight on which one is that? Okay. The teacher claims that the second method used on group 2 will increase the score. So this will be the hint for you for the alternative hypothesis. Okay. So we are analyzing two samples. So the null hypothesis always say that there is no difference between the two samples, but the alternative hypothesis, for the alternative hypothesis, it depends on the statement or the question. Yeah. So let's say H mod, okay, it should be subscript, the one a little below, not the same level like that. Mu, this one is, I cannot use the right symbol, I just use mu one. The group 1 should be equal to mu, or the mean of group 2. That is the null hypothesis, right? But the alternative hypothesis, when we go to the summary of the steps just now, we say that the mu of group 1 is not equal to mu of group 2. That is the general situation. We know that it will not be equal, but not equal can be less. The sample 1 can be less, or sample 1 can be greater than sample 2, okay? But if it is not given in the question, any information about less or more, you can just use not equal. But in this case, since it is given, since it is stated that the teacher wants to justify the claim that the group 2 will increase the score, it means that you have to go back to the question. You have to go specific to the question, what is needed. So you have to state that group 2 is greater than group 1, okay? So no longer not equal, because in this case is given the information. So that's how you construct the alternative and the null hypothesis. The null hypothesis, there is no much problem, because you know that it's always equal, there's no difference. But alternative hypothesis, it depends on the question. Okay, what kind of information is given? If it is not given anything like more or less, you can use the word not equal. But if it is given, you have to apply what is asked, whether less or more. Okay, so that is the first step. Okay, let's go to the solution. Okay, so I've mentioned just now about the first step. Okay, set the hypothesis. Second step is to set, is given actually, alpha 0.05. Okay, the third step is to compute Z, right? So you have to apply this formula, Z equal to x1, x3 bar, the mean. Here you have to be a little bit careful, yeah, with the square root for the denominator, the term for the fraction, the bottom fraction, yeah, we call it denominator. So some of the students might forget during the workout, there is a square root. So you might get the wrong value at the end. So make sure that you don't forget to find the square root value of the term over here, okay? So this is standard deviation 1 and 1, standard deviation 2 and 2. So the value of Z is minus 2.23. Don't forget the negative sign as well, right? So, sorry, this one, oh yeah, minus 2.23. So if you sketch the Z value on the graph, so minus 2.23 is somewhere on the left, right? Because it's negative. Yeah? Okay, so that is the third step. The fourth step is to compare the Z table and Z calculated, right? So alternatively, you can also find the p-value, right? Let's say here we use the p-value method, like the option 2 method. So we have to find what's the p-value or the tell area enclosed by when z is equal to minus 2.23. So in the table, is only on the positive axis, but we know that the distribution is symmetric. Symmetric means it is the same on the left and on the right. So you can apply it, okay? You can find the area on the right side. I hope you know what I mean. So you find from the table what is the tell area. It's given here 0.0129 from the table, okay? It's actually not straightforward. You have to find the first the area enclosed from 0 to z, and then you subtract that area with 0.5, because we know that the total area for each of the site is 0.5. Okay, so 0.0129. I hope I don't have to explain that. So that's how you got 0.0129, the tell area or the p-value, and you compare with 0.05, the alpha. Okay, that is the rule to compare the p-value with the alpha. So in this case, 0.0129 is less than 0.05. So the decision is to reject the null hypothesis. Okay, so that is decision. So conclusion, you have to mention in proper sentence, right? At the at the 5% level of significance, there is sufficient evidence to show that the second teaching method increased the population mean on the exam. You reject the null means that you accept the alternative hypothesis. So it means that the score of mu2 is greater than mu1. So that's how it's you state the conclusion. The second teaching method is better or increase or more than the mu1. I also can accept it. It's not in this form. Okay, so that's the conclusion. So those are the steps needed to be performed. It's quite actually, because you have studied the previous topic, perhaps you can find the similarity, and the only new thing is the Z formula over here, which will be given to you, but it's just that you have to know how to use it, and the rest is the same actually, make decision, conclusion, and the hypothesis is a bit different. You have to insert the sample 2, right? Because now you are comparing the two samples. Okay, any questions so far? Guys?
So far, so good at that.
So far so good. Okay, good. So that covers, if we just go back to what I mentioned in the beginning, the hypothesis testing. So that covers here, this thing, the two samples with known, you can see the screen, this picture, right, on the ellipse. Okay.
Yes.
Okay, yes. That covers the two samples with known standard deviation. Okay, you can see the formula of Z over here, the same, right? Okay, now the next, that is lecture 6. Lecture 7 is about here. The two samples with unknown standard deviation of population or of the samples. Okay. Right, that will be lecture 7. I hope we can just continue. Later we can, you can ask me if you have any question. Okay, lecture 7. Oh, sorry, I'm sharing. Okay, so lecture 7 is about when the standard deviation of the two samples are unknown. Okay, but here it is, the title is two sample t-test, because for unknown standard deviation, we have to use t distribution, remember? from the previous topic. So that's why it says two sample t-test, because we have to use the t distribution. Yeah? Okay, so here is when the standard deviation are unknown. Okay, so there are two types of samples. Okay, both are two samples, but the type of the samples is not different. Okay, the first case is when the samples are independent. Yeah, so what is meant by independent? The samples are not associated. That's what is independent. It can stand by its own. Yeah, and the samples are usually randomly assigned to two groups. Okay, so dependent samples, samples that are either two groups paired or match on some variable. Okay, so it will somehow, the hint will be given in the question. So later we can see how we can know whether the samples are dependent or not, are dependent or independent. Okay, so is the samples for dependent samples is either two groups paired or match, or the same people are being tested twice. This one is a bit easy. You can see see from the problem that it involves whether or not it involves repeated measurement. Okay, so what is meant by the same people being tested twice? Meaning to say that the situation will be normally something, for example, like if let's say the research is about to test the efficacy of effectiveness of medicine, yeah, certain types of medicine, okay, something like that. Perhaps the benchmark or the things to be measured is like the glucose level, yeah. Okay, so let's say the same group, the same people, their glucose level is tested before they take the medicine, right? So that is before, right? And after they are given medicine, their glucose level is measured again, but it refers to the same group. Okay, so that's what is meant by repeated measures. Example of repeated measures. It can be not only the drug, it can be certain things like perhaps maybe food or whatsoever method. So what I gave just now is just an example. Okay, so in that case, the samples are dependent, yeah, or they are matched, they are paired. Okay. So for when the standard deviation of the two samples are unknown, so you can know from the question that the standard deviations are unknown because there is no information given. Okay, so you have to know by yourself that okay, now the standard deviations are unknown. You have to use t-test. Okay, so unlike the first case just now where the standard deviations are given. So you have to use t-test, and what you have to know more is, oh, okay. So first we have a look at independent samples first, independent two samples. So there are two situations. I just go straight to the point. I don't go word by word here. So there are two situations where the variance of the two samples are pooled. Okay, pool means accumulated, and when the variants are separate or different. Yeah, so those are the two cases under independent samples. Okay, so you don't have to worry about separate variants. This will not be asked in the exam or will not be focused in this course. Okay, but what you have to take note is the pool variances. The pool variance means when the variance is assumed equal. Okay, so there is a formula for pool variance, S means square. S square is variance in general. When there is a P here, it refers to pool variance. So this is the formula. It will be given in the exam, but you have to know by yourself that this is pool variance. And you have to calculate the pool variance in order to include this term into the T formula, because in this case, right, the standard deviations are unknown. You have to use T distribution. You have to calculate T, and you have to compare with the T table later. So this is the extended formula of T. Just now we have the extended formula of Z, right, in the previous case. So this one is T, and in this formula, there is this term SP square. So that's why you have to find SP square first. Yeah. So the terms here, x1 is the mean of sample 1, x2 the mean of sample 2, n1 is the sample size of sample 1, and n2 is the size of sample 2. Okay, and here you have to be very careful because the term here, the whole thing is square root, right? Inside the square root, the SP square value is multiplied with the term with this fraction. Okay, so I would suggest you solve SP square value separately, then you get the final value and put it into here. Or maybe if you want to solve this term first, you put it into here in order to avoid the mistakes. Because if you have a very lengthy workout, you tend to make mistakes. Yeah. So that's how you organize in your workout. You have to be very organized in order to avoid careless mistakes. Okay, so that's the T formula. So what you have to find out next is, just go through the steps here. Okay, we are here just now. T computed, okay, and then you have to find the tabulated T. It's actually the same. You can see the same pattern. Yeah? Now you have to find the tabulated T. So how to find the tabulated T? Oh, sorry. In this step, you can choose either option 1 or option 2, right? Option 1 is the same. You compare T computed and T tabulated, but first you have to find the tabulated T. But how to find the tabulated T is the same as, should I explain it? I think I've explained it in last week. So it depends on the alpha value. Let's say the alpha value is 0.05, yeah, which you define in the second step. Okay. So that refers to the tile area of both sides. So if you want to consider only one side, is 0.025. Okay, let's say one side. One side is 0.025. You have to divide by 2. Okay, so what you have to do with this, you have to use the T table. But first, in order to use the T table, you have to find what is the degree of freedom, because you need that information. Okay, for the degree of freedom for 2 samples, the formula is given as here just now. Previous slide. Okay, this one is the degree of freedom for 2 samples, n1 plus n2 minus 2. Okay, n1 plus n2 minus 2. Okay, so that will be the df. Okay, so I don't have any value here because we are not into any example. So let me show to you how to use the T table in order to find the tabulated T. Okay, so this is T table. Okay, so this is T table. So just now, let's say the alpha is 0.05. You divide by 2, you got 0.025, right? So that's the tail area. That this is the area that you have to refer, 0.025. And the degree of freedom is on the leftmost column. Okay, it depends on what is your degree of freedom. That will give you the T value. So the values inside here is the T values. Okay, tabulated T. So that T value is the one that you are going to compare with the T that you calculated using this formula. Okay. Okay, this is, sorry, this is, okay, see. So you computed T using the formula just now, right? So T tabulated tadi, you get it from the table, you compare, and you make a decision. Okay. So option 2 is the same like what I explained for the first case just now, where you have to find the P value of now is T. Okay, so you make decision, and the final step is to make a conclusion. You make conclusion, you have to write proper sentences based on the problems that you analyze. Okay. Right. Any questions so far for this? Let me summarize the steps. This is when both the standard deviation are unknown, and we are talking about independent samples. Yeah? The samples are independent, are not associated. So how you construct the hypothesis, the null is the same as the previous one that I explained just now. There is no difference between the two samples. For the alternative, there is a difference. But again, this one depends on the case. If let's say it is stated in the problem that one sample is bigger or less than another, you have to mention it specifically. Okay. The second step is to set the alpha is even or not. You have to define 0.05 or 0.01. Okay. And then what is different in this one is this part. You have first to calculate SP, full variance. This is the formula. Only consider full variance. I'm not talking about the one that are different just now. And after you calculate the SP square, you substitute the SP square term into the T formula. This is T computed. Okay, you keep the value because you want to compare with a tabulated T. So you have to find the T from the table based on the steps that I mentioned just now. You have to use the tell area information and the DF. So it means that you have to find DF. Yeah? And you compare the two values and you make decision. And finally, you make a conclusion. Yeah. Okay, so that's all the steps. I hope that is not something so difficult, but it's just that you have to view the things like accordingly. Like this is for unknown standard deviation. Just now, the Z is for known standard deviation. Okay. So this is an example of question. Let's have a look at this question. In a packing plant, a machine packs cartons with jars. The time for both new and old machines to pack 10 cartons are recorded. The results in seconds are shown in the table, in the following table. So this is the first sample, the new machine, and the second one, old machine, the second sample. Is given, not the previous one, no? And the deviation. The deviation plus 1 is 2. Do the data provide sufficient evidence to conclude that on the average, the time taken for the new machine to pack is different from the old machine? Perform the required hypothesis test at the 5% level of significance. Assume the data come from independent normal distribution and equal variance. Okay. So what is meant by when I say just now the standard deviation is known or unknown? It refers to the standard deviation of the population. Okay, let me correct. I think I've mentioned wrongly just now. Standard deviation of the population. Okay. So here is given S1 and S2. So that's how you use it in the SP. But what will be the key points for you to differentiate this data from the known standard deviation is this point. The data came from independent, right, and equal variance. Okay, so if you see the first example when the standard deviations are known, let me show you lecture 6 just now. Huh? Okay, so this one, So this one is under non-standard deviation, when the standard deviation of the population is known. Okay. It's also given S1 and S2, or this sigma 1 and sigma 2, but it doesn't give you the information of just now, the additional information like the independent samples, equal variance. Okay, that will be the difference. Okay. And this one. Okay. So here, assume the data came from independent, normal distribution, and equal variance. Okay, this will guide you to unknown standard deviation of the population. Okay, under independent samples. So here, what you have to do, this is the formula that you have to use actually. Okay, so the step is, so this is the information, the hypothesis, the mu1, or you can write it specifically, or you define here a new machine as mu1 or 1, and all machine as the second sample S2, so that we know what is mu1 refers to. Okay. Okay, another thing is, it's not given. Okay, so the key point here, do the data provide sufficient evidence to conclude that on the average, the time taken for the new machine to pack is different? So the idea, the key point here, different. That will guide you for the alternative hypothesis. It doesn't mention whether new machine is more or less than the old machine. So what you can write for the alternative hypothesis, okay, is not equal. Okay, ataupun you boleh letak the mu2 on the right side is not equal, or this one bila dia ditransfer ke sebelah kiri lah actually, yeah. Okay, so not equal, it's not less or greater. Okay, so the second step is alpha is given, right? Is it given here? Okay, 5% level. Okay, you have to mention somewhere. Alpha is 0.05, but here I didn't mention it. And the next step is to calculate the pool variance SP squared based on this formula. Substitute the values given, you get 0.5145, right? And the next one is to compute the T. You use this expression and substitute SP squared into this. You get minus 3.398. Okay, and then you have to find, this is T computed, and you have to find the T table if you use the option 1. T table, it means that you have to find the T from the table, but first you have to find the degree of freedom, N1 plus N2 minus 2. Yeah, N1 is 10, N2 is 10. So DF is 18. Alpha is 0.05. Okay, because we want to use only one tile area because it divided by 2, and the table is only given one side. Okay, so you have to use 0.025. Okay? 0.05 divided by 2, 0.025. So you get the T from the table is 2.101. Okay, so now the T computed is minus 3.398. Remember, if you make the decision, the comparison should be the absolute value. See the bar there? This the symbol. Okay, don't forget, don't confuse with the negative value just now. This bar means you only consider the positive values. Okay. Yeah, don't forget this bar. So although that the T computed, you get minus 10. But because of that bar, it only assume, or it only considers the positive value, which is 3. So now you are comparing 3.3 and 2.1. So obviously 3.3 is greater. So here you conclude the H0. If you forget that rule of bar, you see minus 3. Minus 3 is less than 2. So it will give you different decision. So make sure that you understand the meaning of that bar. Okay. So this one is the second method. If you use the p-value, Okay, you just use one method, right? It will give you the same conclusion actually, the same decision. Yeah, whereby here is you accept or conclude the alternative hypothesis. Okay, so that is decision, not yet conclusion. So conclusion, you have to write proper sentence like this. At 5% level of significance, we conclude that the time taken for both machines to pack is different. Or if you construct the sentence like the mean of all machine is equal to the mean of the new machine, also correct. Okay, but that is the conclusion that you have to write proper sentence. Okay, so that conclude the all steps that we discussed. Yeah, how to apply it and how to answer the question, related question. Oh, okay, this one is another thing. So sometimes before this we have studied confidence interval, right? So when we talk about confidence interval, we want to know the range of the distribution. Yeah. So in the exam, those questions can be asked together with this question. Although that confidence interval we have studied before, but it can be like attached together or combined together with the questions from this topic. Okay, so here, let's say using the example before, give a 99% confidence interval for the difference between the mean time it takes the new machine and old machine to pack 10 cartons. So what you have to use the formula, this is the formula that you have to use. Okay, so let me highlight what's the important thing. So this is the things that you have to plus minus. It's not only the mean of one, but the difference between the sample one and sample two, and the whole thing here. Okay. This T is the one from the table. Yeah, T tabulated. T table. Okay. And then SP is the pool variance. Yeah, but SP, only SP. You buang the square root, you find the S only. Okay, and multiply with the square root of 1 divided by N1 plus 1 divided by N2. Okay, let's say in this case, it gives you a new information whereby you have to use alpha equal to 0.01, not 0.05. So you have to find the new T. That's why in this case, the T is different from the previous T table. Okay, because here the tell area is different. 0.01 divided by 2 is 0.005. Okay, this is the T given by that tell area. And once you have the information, you just substitute into this expression, the whole expression here. The T value, the SP, and the square root of this, right? So at the end, you will get minus 1.09 plus minus the whole thing here. I don't know what's the value of here, but it will give you this value. Okay, let's say, let me calculate this one. Hold on, I try to calculate this value. Okay, so the value here is 0.923. Okay, the whole value here, after I multiply 2.878 with this and this, is 0.923. So minus 1.09 plus minus 0.923. Okay, let's go for plus plus. Minus 1.09 plus 0.923 is this one. Yes, 0.923 is minus 0.17. Okay, if let's say minus 1.09 minus 0.923 is minus 2.01. So that is the range, and the range goes from minus 2.01 to minus 0.17, because in negative values, remember when it's negative, negative macam ni, kan, this is like 0, right? Okay, so this is minus 2.01, and this is like minus 17, right? So it goes, minus 2.01 is actually much smaller than minus 0.17, right? So that's why we write minus 2 first, not, it's opposite with the positive values. If let's say we have 0.17 and 2.0.1, we can say that the range is from this and this, right? From 0.17 to 2.01. But for the negative values, whatever the bigger value is, the smaller. So that's why the range is from minus 2.01 to minus 0.7. So that answers this sub-question. That is a 99, give a 99% confidence interval. So they want to know what is the range of the data. Okay, any question? I don't have, oh, this is another example. I didn't know the office. I thought the office. Okay, you go through the example by yourself. Actually, it's the same thing. Yeah? It's just another different problem. Yeah, but both are, but this is still independent, yeah, and separate variables. So you apply the same steps as what I discussed just now, but this is just another problem now. Okay, so I'll go directly to the next topic. Dependent t-test. Okay, just now it's independent samples or independent t-tests, because the samples are independent. But now we are focusing on dependent samples, when the two samples are dependent, are packed, are associated with each other. So what kind of examples of samples are there? Packed samples, for example, examination of the hearts of men and women in a relationship status. Okay, means that it's needed pack one man and women. Okay, that's why it's packed. Okay, repeated measures, examination of pre and post test. This is what I said just now. The same person, the same group of people. Okay, they are measured twice. Yeah? For example, like here, they are measured for their performance in test 1 and then test 2, but they refers to the same person. So this is repeated measures. And they are examples of match or dependent samples. Okay. So the formula that you have to use for this is this: T equal to D. D is the mean of the path difference. Like I'll show later how to find the D. And then divided by the square root of S divided by square root of N. Yeah? So S is standard deviation. So this standard deviation, you have to use the formula. Let me show the formula. The formula that we use in lecture 1, early 1. Hold on.
Yes. Why we also practice why
This formula. Okay. Okay, now we are here. We are talking about dependent samples or matched samples under unknown standard deviation of population. And this is the formula of T. Okay, and in order to use the T formula, you have to first solve for S. And S is obtained from this formula, S square 1 divided by n minus 1, summation of x minus x bar square. S is the square root of S square. Okay, so this is from a new one. It's not a new formula. You have used it before. Okay, let's go back to my slide. Okay, so how to use this formula? What is meant by the D? Yeah, by the D, yes. Okay, let's say you are given two samples, dependent samples. Example is something like before and after measurement. Yeah? So how to calculate the D? So you have to construct this sort of table, right? Make it vertical. It's much easier to see rather than it's horizontal. So the first sample is the one before, and the second sample is after. D refers to difference, yeah? The difference between the two samples. Okay, so for each of the data, the matched data over here, you have to find the difference. Right? 312 minus 300 is 12, 242 minus 201 is 41, and so on until the end of the data. And at the end here, you have to sum the difference. 12 plus 41 plus 108 plus 76 plus 76 minus 2 plus 63 plus 72 plus 59 is equal to 505. Yeah, that is the summation of D. And then N is 9 because each of both of them are similar. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, the sample size. So the D bar refers to the average of the difference, which is equal to 505 divided by 9. That gives the value of 56.11. Okay, is it clear? Okay, so that answers how to find the D bar value. This D1, D1, D bar, right? Okay, the S value here is you apply the formula tadi lah, yang S square tu. Yeah. So S square, I think you know how to use it. Yeah, that's the S value given in this case is 34.174. So the T in this case is 4.9257. Okay. That's how, I think this is not a complete, is it a complete example? Oh, it's a complete example. Okay, okay. Okay, sorry. I didn't read the problem before. Okay, this is an example of a problem that involves dependent samples. Okay, go back. I go directly to the D just now. Comparison of peak expiratory flow rate before and after a walk on a hot day for a random sample of 9 asthmatics. Perform the required hypothesis test at the 5% level of significance. So this is before and after. So the moment you see data involving before and after measurement, you by right you should know that it's straightforward. It's a match. I mean the data, the samples are matched, right? And it falls under the category of the match or dependent samples under the unknown standard deviation of the population. Okay, right. So you want to check whether or not the data before is different with the data after. That is the idea. Okay, so the hypothesis, by applying all the steps that I mentioned just now. Okay, the first step is to write the hypothesis. Yeah. So the null means that there is no difference, and the alternative, since that it doesn't mention anything in the question, right? So you just use the sign of not equal. Okay, So the level of significance is given 5%. Somehow you have to write it here. Okay. And the next step is to calculate T. Yeah. So you have to use this T because it is the formula for the match samples, right? So that's why it's very important for you to identify the problem. When it is given before and after, you have to know that it falls under the category of dependent samples, and you have to use this T formula, not the T formula for the one that has SP square. Okay, that one is you have to decide by yourself, because you have to understand by yourself the problem, the situation. Okay, so what you have to do next, I explained just now the D just now, right? That's how you use this formula by finding the D bar and the S from the formula of S square. And then that's the T value. Okay, that represents T computed. So you have to find the T tabulated, right? So the T tabulated is found from the table. So the degree of freedom for this situation, n-1, not n1 plus n2 minus 2, is different. You have to differentiate the DF formula as well. The alpha is 0.05, that is the tile area. You have to divide by 2 in order to find the T value. So the T value is obtained by using the information of 0.025 and DF equal to 8. That is given as 2.306. Okay, so it's less than the P computed, right? So based on the decision, the rule of the decision, in this case, you have to reject the null hypothesis, or you have to accept the alternative hypothesis. You can either mention reject null, or you can say accept alternative hypothesis, which carries the same meaning. Yeah. So the conclusion is, you reject the null means that you accept the alternative. So it's not super greater, it should be different. Let me correct this. If you have downloaded the notes, please cancel this one because it's not given in the question, greater or less. So you have to say that it's only different. Okay. So the conclusion is the experience. So this is what I mean by being specific. You cannot say that mu1 is just different from mu2. You have to go back to the question. So in this case, it talks about the aspiratory flow rate before and after work, right? So that is the specific information. So that's why you have to be specific when you state the conclusion. You have to say back what the things are measured. The aspiratory flow rate before and after work is different. Okay, don't repeat the alternative hypothesis by just using the symbol, everything. I don't want to see that. Conclusion is when you state the proper sentence. So why we emphasize this? Because in your research letter, when you want to tell people in your report, in your thesis, at the end of your studies, you have to prepare what we call thesis. Is a final year report. Okay, you have to write down all the conclusions of your research, small research project that you carry out in your third year. So in your conclusion, it's very important for you to tell people what, to be specific. It's not just to say that sample 1 is not equal to sample 2. People do not know what sample 1 you are analyzing or what sample 2. You have to introduce back the things. Sample 1, you can say that perhaps you're doing like distribution of birds. Is not in Cebu or in whatever, it's not equal to the, or it's different from the distribution of birds in Miri, something like that. So that is what I mean by being specific. You cannot say that only by denoting as S1 or A, B, or 1 or 2, okay? So please, in your exams, be specific when you state the conclusion. Okay, so that is what lecture 6 and 7 is all about, basically. Lecture 6 is when we talk about the two samples, both are two samples, but lecture 6 is when the standard deviation of the population is known. right? We use Z distribution. And then when the standard deviation of the population is unknown, we use T distribution. This one we cover in the lecture 7 actually. And we have two situations, independent samples and dependent samples. So you have to identify the problem correctly in order to use the right T formula, because each of these situation has its own T formula. Okay. So just go back to this one, Elgin, which is actually the same as this picture, this summary. Yeah. Okay. Two samples with known standard deviation of the population and unknown standard deviation of the population. We use T formula or T distribution. That's why it's called two sample T distribution. So under the T distribution here, we have independent samples and dependent samples. You can see that there are T formulas for each of this situation, but you have to know, you have to analyze the samples and whether they are independent or dependent. Okay. Under independent samples, you have to find the SP or the pool variance, where you substitute the pool variance into the T formula. In the dependent or batch samples, you have to use this T, which is much simpler, the formula. But first you have to find the D. The D bar is the average of difference. Yeah? So I explained just now how to find the D for each pair. Okay, and then you sum the whole D divided by the sample size. Sample size is n, only n, because when it is matched, of course, it has the same sample size. So this actually the number of pairs, the n refers to the number of pairs. Okay, so it's only one n divided by n. Yeah, this one n. Okay, and how you get the s is from this formula, s squared. Yeah? So this is the formula that you have used in every one. Okay, that's wrap up lecture 6 and lecture 7, and the end of LU2 actually. So we have finished LU2. Any questions so far? Okay, so I have some questions over here, but I hope that you can do by yourself at home, yeah? Because I don't want to waste your data just to, just for you to spend here. Okay, so I have 4 questions. 4 questions, yeah. So this kind of question is like the questions that we're going to ask in the exam. So familiarize yourself with the question, yeah? Okay. And this one are all related to. This one that I do different. Oh, okay. So in the first question here, it is mentioned the difference is given to you, but more often than not, you have to find by yourself. Okay, the difference. But in this case, it's given. Okay, so I hope you can do it by yourself. I will give the answer later on Elite. Okay, so any questions so far for LU2? So we have finished LU2. For the next week, we have the break, 1 week, and the mid-semester exam will be held. We don't have the date yet, but it's after the mid-sem break. And I will inform later anything on the exam, on Elite, and also on the Telegram. Okay. The LU covered, okay. LU covered is LU1 and LU2. I'll tell the format later. Don't ask me the format yet. Okay, I'll inform the format later. But you have to cover LU1 and LU2 for the mid-sem exam. Okay. Any question before we discuss? Guys, you're so quiet. Yes?
Oh my God.
No question? How about previous lectures? Have you guys go through all the extra exercises and you get the answer? Or if you don't get the answer, do you know why you don't get the answer? I will try to make some video tutorials, inshallah, yeah, before your mid-sem break, just to guide you with the solution, how to solve the problems. Okay. I'll try to choose like some exercises from the extra exercises that I gave you, perhaps from these extra exercises. Okay, I'll try to make a video tutorial. So just go to, I will give the link later that once I have the video. So normally I will post the videos on YouTube channel, the one that I mentioned on ELIP, no statistics, no talk. I hope you realize the existence of that YouTube channel. You don't, I don't force you guys to subscribe, but you have to follow it. Okay. Okay, Muhammad Firdaus, manual attendance. Okay, yes. Okay, attendance. Siapa lagi yang tak attendance tadi? So, while some of you scan for their attendance, do you guys have any questions about the mid-sem exam? I will update from time to time once I get the information, because I need to get the latest info from our coordinator, the Siti Lydia. If you miss out any lecture before and you're not clear with anything, you can email me, because I don't really mind about your attendance. Not to say that I don't really mind, but what matters more is whether or not you understand the lecture that I delivered on that particular day. Okay, so feel free to ask me by email if you have any questions. All right, if there is no more, anyone more for attendance? Tadi siapa tadi? Muhammad. You guys, tadi soalan? Semua faham ke? Apa dia soalan tu? Christina Fatimatul Zakira, are you here? Okay, well, that's very good. If you don't need any more explanation. Okay. All right. Thank you for your attendance and for your patience. Yeah. We'll just finish here. Okay. All the best for the mid-sem exam. And anything I will just update on ELIP and on the Telegram channel. Okay. So just keep updated from time to time. All right. Thank you very much, everyone. Have a nice day. Have a good break. And stay safe. Okay, bye.
Thank you, doctor.
All right. Welcome.
Thank you, doctor.
Welcome.
Thank you, doctor.
Welcome. Take care. Welcome. Yes.
Because he suggested us with same action by the children to actually get the list of